All right, everyone, let's get started. So our topic today is about real numbers. Okay, we're gonna see what real numbers are. Then we're gonna use the number line to learn some rules of addition, subtraction. And later, we're gonna learn some multiplication and division of real numbers. But first, let's define them and then use a number line to basically graph them. So as always, we're gonna start with the definition. So basically, all the numbers you might think of right now, any number in any form or sign is called a real number, unless you're thinking about complex numbers. That would be a different group. So basically, the group of real numbers, or the set of real numbers, is made of subsets. First, have the what we call the natural numbers. So natural numbers are numbers that start from 1 and go up. 1, 2, 3, and so on. No negatives, no decimals, only fractions. Start from 1, no 0, just these numbers, 1, 2, 3, all the way to infinity. After this, we have the new group, which is the group of whole numbers. The group of whole numbers, basically, we just add 0 to this, and it turns into a new subset of the real numbers, which we call the whole numbers. So we add 0 to these, 1, 2, 3, and so on. Okay, so as we go, the group would grow. So natural numbers, then whole numbers. After this, we need some negatives. We need some negatives on the left side of 0. So it will be 0 here in the middle. We have positives on the right. We have some negatives on the left, -1, -2, -3, and so on. So these go towards positive infinity, and these go towards negative infinity. It gets smaller and smaller and smaller. Okay, so this is what we call integers. Okay, so integers include all these in addition to the negative numbers. Okay, so after this, we're still missing the decimals and fractions. So once we add all that to this, we're gonna get a new group called the group of rational numbers. Rational numbers. Okay, so that group basically contains all the above. Okay, all the above plus decimals, also known as fractions. So decimals are basically another form of writing fractions. Example 1/2, that's a fraction. As a decimal, it's expressed as 0.5. Maybe 3/4, 3 out of 4, that's 0.75. Maybe 1 out of 3, which is basically when you divide this, you get 0.333. It doesn't end. It repeats and it never ends. Okay, so that's what we call rational numbers. Could be an ending decimal like this, or could be non-ending, non-repeating decimals. So rational numbers basically are ending decimals. And non-ending repeating decimals. Okay, repeating. Okay, the two things here, either ending or non-ending, but repeating decimal. So this is a non-ending repeating decimal that makes it rational. These are ending are also rational, but sometimes the decimal can be non-ending but non-repeating. So it would be the opposite of this. In that case, it would be called not rational, but the opposite would be irrational. So it would be non-ending and also non-repeating. So we call the another group of irrational. Irrational numbers, basically non-ending, non-repeating decimals. Okay, and as an example of that, we have a famous number pi, which is a decimal point. This number is a constant. It's 3.14, 15, I believe 65, and so on. So the thing with this number is it's irrational because it's a decimal, but that decimal doesn't have a pattern. Here we have a pattern, but this one does not have a pattern. It does not end, it does not, it repeats, but it does not end. So non-ending, non-repeating, just some random non-ending number. So 14, 15, 92 actually, and then 65. Okay, it's 92 here. You can see there's no pattern here. Just 14, 15, 92, just random numbers. So it doesn't end, it does not repeat. That's what makes it irrational. As opposed to this one is non-ending, but it repeats in a pattern. For example, here 333, or it could be some decimal like this. Let's say 82, 82, 82. That does not end, but it repeats in a pattern like this. Or it could be 3 digits that repeat. So that's the difference between rational and irrational numbers. So if the division ends, it's rational. If the division doesn't end, but it repeats in a pattern, it's also rational. If it's the opposite of this, it means if it doesn't end, it does not repeat, it's irrational. As an example, radical 2 is also irrational because radical 2 is basically a decimal that doesn't end and it does not repeat. So radical 2 is basically 1.41, 42, 13, and so on, 13, 56. As you can see, there is no pattern here. Random numbers generate and nothing repeats. You just random numbers as opposed to this. So that's basically what we mean when we talk about real numbers. It just means all these numbers, which is split into subgroups or subsets. Each one has specific numbers in it. So natural, 1, 2, 3, and whole number, integers, rational, and irrational. So all these subgroups belong to or are in this group or set of real numbers. The symbol for real numbers is R, like this, with 2 vertical lines, then this. So that's R. We have another group called C, the group of complex numbers, which includes all this and some other numbers, but that's not the subject of our class. We're only going to be dealing with the real numbers in this class. So next time you hear real number, it just means any number basically you can think of any form, any sign, not including complex numbers. Okay, does that make sense, everybody? Any questions, guys? Does that make sense so far? Can't hear you, your mic's
Yeah, it makes sense so far.
Okay, everything's good. All right, so now that we defined these real numbers, let's see how to put them on a number line. So The second thing we're going to talk about is the number line. As the name implies, it's just a line with numbers on it. Okay, basically you can think of it as a one-dimensional graph, just one dimensional graph, straight line, like this. In the middle of that line is the number 0, the 0 that we talked about here. And then to the right of that number we have positive numbers, to the left we have negative numbers. So 1, 2, they are the same distance, the numbers are the same distance from each other. That's basically the scale of the graph. 1, 2. Okay, as the numbers grow here, they get bigger and bigger to get to infinity, the imaginary number, or the highest possible number if it exists. And the other side, we have numbers that are negative. So the numbers get smaller and smaller as we go to the left. So -1, -2, -3, and so on, all the way to -infinity. This is the smallest possible number, and this is basically the highest. This is positive infinity. The other side is negative infinity. -4, -5, and so on. So as you go this way to the left, the numbers get smaller. For example, -1 compared to -5. -5 is smaller than -1. The numbers to the right are higher than the numbers on the left. Any number, for example, here, this one is higher from any number from this side. So 0 is basically higher than all the negative numbers. 0 is also smaller than all these numbers on the right. -2 and -3. -2 is smaller. I mean, -3 here is smaller than -2 because it's located on the left. So as you go to the right, the numbers get higher. For example, -4 compared to -1. Obviously, -1 is on the right side, so it's higher than -4. Now we can put numbers, random numbers here on this graph. Let's say, I want to put, let's see. So let's put a few numbers here, maybe -3. Probably 1/2. Also, we're going to try to put pi. Basically, any number of any sort you can think of, 1.5. Maybe 2 or 3 to the second, or, oh no, 2 to the second. So any real number in any of these forms basically can be placed on this number line. So if you look at the first number 2, it's positive, so it's got to be on the right side of 0. So 0 is here, so 2 will be right here. Then you have -3. Obviously, that's a negative number, so it's got to be on the left side of the 0. So that's basically -3. Then you have 1/2. 1/2 is a fraction. Before we put fractions on the number line, we need to turn them into a decimal. So basically, 1/2 again is just 0.5. 0.5 is a positive number. Obviously, it doesn't have a negative sign. It's higher, a little higher than 0, so it will be between 1 and 0. So half is right in the middle. So right here, 1/2. Then pi, which we saw earlier, pi is here, 3.14. So that will be between 3 and 4. Just a little over 3, okay? Just 3.1. As you go from your 3.1, 0.2, 3, 3, 4, 5, 6, all the way to 3.9, then 4. The 3.1 is very close to 3, not to 4. Okay, so somewhere over here, you'll have pi, which is 3.14. And finally, the next one is 1.5, 1.5. That's 1.5. That would be between 1 and 2. Obviously, it's positive, so it's got to be on the right side. So that's right in the middle of 1 and 2. We have 1.5. Finally, 2 to the second, which is basically another form of real numbers as an exponential expression, as we saw in the last class. 2 to the second is basically 4. It's also a real number, so apparently it's right over here. So 3, 2 to the second is basically right here. Yeah, so this is what we call real numbers, all different forms, types, shapes, signs, and those can be graphed on the number line. If something is not a decimal, turn it into a decimal first. If it's a fraction, turn it into a decimal. If it's already an integer or a decimal, it has a place on the graph of real numbers. So that's basically the graph of real numbers. So the reason why we talked about this graph, because we're going to use it to add and subtract real numbers or integers. So especially integers, we're going to be doing a lot with integers today, mainly this. So we have negatives, 0, and positives. So we're going to see how to use this number line to add and subtract them. And then we're going to write some rules. We're going to conclude some rules based on that number line. So before that, so as we saw earlier, we said when we compare numbers, the numbers on the right are higher than the numbers on the left. When you look at the number line, the number, if you compare in two numbers, the one on the right is always higher than the one on the left. Be careful when you compare, especially negatives. So let's say, so compare in real numbers. So let's say you want to compare, I don't know, 3 and 2. Then I want to compare 0 and 4. Then -1, -3, -4 and 0. Then let's compare -2 and -100. Okay, so start with the first 2. So 3 compared to 2. If we use a number line, so 3 is located to the right of 2. So the numbers on the right are always greater. So 3 is greater than 2. Then this one, we have 0 and 4. Obviously, we know that 0 is less than 4. You can also see it from the number line. 0 is here, 4 is here. The numbers on the left are smaller than or less than the numbers on the right. So this is less than 4. 0 is less than 4. Now this is where it gets a lot tricky when you have negatives. For example, -1 compared to -3. What's -1 compared to -3?
-1 is less than -3.
And why do you say that? So -1 is here.
Actually, no, -1 is more than -3.
That's right. So -1 is here, -3 is here. The numbers on the right are always higher. So -1 is actually greater than -3. It may look smaller, but it's a negative. So what's better, losing $1 or losing $3? So you say, I'd rather, it's probably better or bigger, or maybe it's better to you to lose $1 than lose $3. What about -4 compared to 0? What is negative?
0? 0 is greater than -4?
Let's read it from left to right. -4 is what compared to 0?
Less than 0.
That's right, exactly. So -4 is here, 0 is here. So -4 is less than 0. 0, in other words, if you read it from this side, 0 is higher than -4. What about this last one here? -2 compared to -100. -2 compared to 100. -100. Is it less than or greater?
-2 is greater than -100.
That's right. So -2 may look smaller, but it's a negative. It's a lot bigger than -100. -100, if we go this way, somewhere down here, all the way somewhere here, you'll find -100. It's much, much smaller than -2 because as you go to the left, the numbers get small. So -2 is less than -100. Okay, so that's basically how we compare numbers on the number line. Now we're going to talk about another concept called the inverse. Property. Also known as, we also refer to this as the double negative. I'm sure you've seen it before. So what it means is, also called double negative. Double basically the inverse property means any number, so we have 0 in the middle, any number from the right has an opposite number or an inverse from the other side. That's exactly what it means. So for example, -3 is on the left side. What is the opposite of -3 on the other side of 0? That would be, is a symmetric number, same distance from 0 on the other side. So we have 3 units from 0 to -3. If you go 3 units from 0 to the other side, you get 3. So -3, we say its opposite, but its inverse is +3. Same way, if we take any number from the positive side, it has negative number on the other side. What is the opposite of +5?
-5.
That's right, would be negative.
-5?
Exactly, yeah. Opposite -5. So that's what we mean by inverse property. And so basically, when you say -3, and its opposite is +3, when we write it, it's actually written like this. When you see a double negative like this, you read the first negative as the opposite of this number. So the opposite of -3, what is it again? Opposite of -3 is?
+3.
+3. That's where the notion of the double negative comes from. If you have two negatives, they turn into a positive. That's the reason why, because -3 is here. You see the opposite of -3 is +3. Same way if you have a minus here and you have, let's say, +2. Always read the first negative as the opposite and then find the opposite of that number. What is the opposite of +2? The opposite,
-2?
that's right, is -2. So next time you see these signs and expressions when you do the order of operations, so think of it that way. So two negatives say, oh, the opposite of this is this, and this one also the opposite of negative, or the opposite of +2 is -2. So that's the notion of double negative. So negative turns into a positive, but negative and the positive turns into a negative. Okay, so that's what we mean by the inverse property of real numbers. So any number from each side, either side of the number line, has an opposite number on the other side. And to generalize this for any real number, let's say some number x. So when you say for any real number x, that x could be any of these numbers we talked about earlier, any of these forms. So x refers to any maybe natural, whole, or any number here. So what is the opposite of -x?
+x?
That's right, +x, whatever that x might be. X could be 1, could be -7, could be 3 out of 5, could be anything. So negative, double negative again, negative turns into a positive. Another notion or another property we're going to talk about regarding these real numbers is called the absolute value. So number 5. So the absolute value of a number. The absolute value, the symbol is this, 2 vertical bars like this. They're not parentheses, they're not brackets like this. They're just 2 vertical lines. Inside goes a number or an expression or a variable like this. Let's say, for example, here, -2. What the absolute value does basically just strips the number of the negative sign. It makes the number, whatever is inside, makes it positive. For example, the absolute value of -2 is +2. The absolute value of, let's say, 6 or +6, it's already positive, so it remains positive. That's all the absolute value does. So we read this as the absolute value of -2 is +2. The absolute value of +6 is +6. So it does not always flip the sign like the opposite does. The opposite is always, the sign is reversed. -2 turns positive, positive turns negative, and so on. But here, with the absolute value, the outcome is always positive. So the absolute value, or the AV, is always positive or sometimes 0. You could find something like this, let's say 3 minus 3. Basically 3 minus 3 is 0. The absolute value of 0 is 0. 0 is an unsigned number. It's neutral, it doesn't have a sign. So just remove the absolute value and you get 0. That's what the case with the absolute value is 0. Okay, so that's all the absolute value does. Let's do a couple examples here. What's the absolute value of 7?
It would just be 7.
That's right, stays positive. The absolute value of -8.
+8.
That's right, +8. What about the absolute value of 2 minus 2? Would be
0.
0. Okay, that's all there is to it. When you hear absolute value, think about these bars, and whatever is inside is made positive if it's not already positive. Sometimes you may see these in, may have expressions. It could be something like negative and negative, let's say 6, like this. So just like the order of operations, when you evaluate algebraic expressions, always look inside the absolute value first. Just like with parentheses, you gotta work inside. This minus is not affected by the absolute value. This minus outside stays here. Then you do, what is the absolute value of -6?
+6.
That's right, it's +6. So this one turns into just 6. So this negative stays here, but this -6 turns into +6. You could also have, let's say -2. Let's say 5 minus 1. Same thing here, we're going to evaluate using the order of operations. Where do we start from?
What's in like the bracket? So 5 minus 1.
Exactly, we're going to start inside the brackets, bring the -2 over. So the brackets, we have 5 take away 1, which is 4. And then finish this. So the absolute value of 4 is 4. What is the operation here between -2 and the absolute value?
Multiplication.
Exactly. Just like with parentheses, when you have, for example, something like this, This means a multiplication. Same thing with the absolute value. Basically, we're going to take the -2 and times it by the absolute value 4, which turned to be 4. Finally, this is -8. Okay, so remember, when you evaluate these expressions, evaluate inside first. The absolute value only affects what's inside. It makes what's inside positive, not the outside. The outside stays the same. The outside here stays the same. Okay, so that's the notion of the absolute value of real numbers. It just turns the number basically positive. Okay, let's do, now we're going to see how to actually add and subtract using the number line. So let's see where the rules come from, addition and subtraction. Okay, so let's call this maybe number 6. And do addition and subtraction. Of real numbers. We're going to see what we call the signed numbers. Another way of saying this is the signed numbers. So we're going to need a number line again for this. So always 0 in the middle. 1, 2, 3, 4, 5. -1, -2, -3, and so on. Made positive here. Okay, let's start with some simple examples. We all know, for example, that, let's add a couple more numbers here. Start with a very simple example of 1 plus 2. We all know that's 3. So let's see how to get that from the number line. Basically, 1 added to 2. So you start from the 1 on the number line. You're located here. Then when you add, you go to the right of that number. So you start from 1, which is located here. Then you go to the right. Addition means go to the right. With that number, how many units? This number of units. So start from 1, go to the right, 2 units. Start from 1, then count 2 units. 1, 2, you land on 3. That's basically how we do the addition on the number line. Same thing with subtraction. Let's say you want to do 5 minus 2. Or minus just maybe 1. We all know it's 4. 5 minus 1 is 4. Let's see how to do it from the number line. The number line. So we're going to start from 5. And where do you go from 5? Left or right? Based on this.
We will go to the left.
That's right. If it's a negative, we go to the left. How many units?
1.
That's right. 1 unit. So start from 5. Go to the left. There's 5. Go to the left 1 unit. So we got 1 unit here. You land on 4. That's why it's 4 here. For the first one, we went from 1 to 2. Start from 1, 2 units. 2 units to 3. Okay, so that's pretty simple, straightforward, no big deal. But this comes in useful when you have some operations that may look confusing. For example, let's say 2 minus 3. That may look a little unusual. You say, oh, how can I subtract 3 from 2? Well, we can do that. So the reason we use this number line, the reason also we have sign, positive and negative. So we're going to start from 2, then we're going to go to the left 3 units. You may already know the answer to this. What do you think 2 minus 3 is? What do you think? What is
Negative 1.
negative 1? Did you think about the number line when you did it?
Yeah.
Okay, so we did it with number line. If we did, maybe if we didn't, if it wasn't for the number line, you could have been confused by this. But again, so we start from 2, go to the left 3 times. These 2 go to the left 3 units. 1, 2, and 3, and you end on number negative 1. And there's also sometimes you may see something like this: negative 2 minus 1. That's 2 negatives. This is not a double negative. Do not confuse that with this. Double negative when a minus followed by a minus immediately with parentheses in between. So double negative turns into a positive. This is not a double negative. This is just negative 2 minus 1. What do you think negative 2 minus 1 is?
Negative 3.
Negative 3. Very good. So we start from negative 2, which is here. Since we have an subtraction, we go to the left once. So negative 2, go to the left once, you land on negative 3. So if you ever get confused with these signs, just draw a simple number line like this, and basically just try to remember the rules. We're gonna write the rules based on this. But this is all you need to know for addition and subtraction rules. There's nothing else to it, just this. These are pretty straightforward and basically don't need much thinking here, but these can be confusing with these minuses. This is what we call signed numbers. So if you ever get confused again, just make a number line. You may also see something like this. So we can do another example. So say negative 4 plus 1. What do you think negative 4 plus 1 is?
Negative 3.
Very good, negative 3. So we start from negative 4, which is here. We have an addition, so we go to the right once. Start from here, go to the right once, you get negative 3. Let's see. What is another one here? 0 minus 1. What's 0 minus 1?
Negative 1.
Negative 1, that's right. We start from 0, we go to the left once, negative 1. And one more example, final one. So 4 minus 5. What's 4 minus 5?
Negative 1.
That's right. So negative 1. So we start from 4. And you go to the left 5 times. 4, 1, 2, 3, 4, 5. You get negative. And that's basically, these rules will apply to any number, even the larger numbers. We're going to see in a moment how to use the rule. We're going to generate the rule based on this and use it. 1 second. Okay, but sometimes you may have large numbers, let's say 100 minus 300, for example. Obviously, we're not going to put 100 on a number. We're not going to put 1, 2, 3 all the way to 100, all the way to negative 100. But we need to basically get some rules from these examples. So the rule is basically this kind of looks like this. Or to make it even closer to it, we can turn this into, let's turn this into 200. So here we used 2 minus 3. We start from 2, we go to the left 3 units, we get negative 1. But these are large numbers. Obviously, we don't want to draw a large number line and count to 200 and count to 300. That doesn't sound practical. What we can do is we can see and see if we can get a rule from here. Let's start from the second one. Maybe it's easier. So we have 2 negatives here, negative 2 minus 1. So we keep that same sign. What happened to the 2 and 1? What did we do with them to get 3? Obviously, we added them, right? So if you have two
Right.
these, that's right. Keep that sign and add the 2 numbers. What about this? We have this 2, which is basically a positive number, is an invisible positive here, and -3. Which sign did we pick? Pick the sign of which number? 3.
The 3, the larger number.
That's right. We keep the sign of the larger number. And then what happened to the numbers? Did we add them or subtract them?
Subtract.
That's right, subtract them. So technically this is a positive. So if you have different signs, keep the sign of the higher number and find the difference of the 2 numbers. The difference of 3 and 2 is 1. But if it's the same sign, you gotta keep that same sign. And instead of subtracting like here, we add the 2 numbers. So those are the key rules here for addition and subtraction. So this again only applies to addition and subtraction. Don't confuse this with multiplication and division. We're gonna talk about this later. So again, different signs, keep the sign of the higher number and find the difference. So let's apply that to here. So which sign are we gonna pick from here? You're gonna pick which sign from these two?
Negative.
The negative?
The negative sign. What do we do with the 2 values? Do we add or subtract them?
Subtract.
Subtract. So if they're different,
Negative 100. Negative 100?
Exactly. Here's a nicer way to remember it. Different signs, find the difference. Find the difference means subtract. Same sign, keep and add. So now let's do another one, maybe negative 400 plus 500. Obviously, again, we don't want to, not plus, let's do a minus this time. Obviously, we don't want to draw a long number line. What's negative 400 minus 400 minus 500?
Negative 900.
That's right. Same concept as this. Keep that same sign. In other words, no sign wins. They're the same thing. The same team, they come together. Here we have 2 different, let's say, teams, 2 different numbers. One of them wins. This one wins by 100. But these come together, so we make them one team. That's negative 900. These are the only rules, 2 rules you need to remember for addition and subtractions. These are the key ones. The other ones are obvious. You don't have to think about these ones that much. So let's write the rules for these. So rule number 1. So if you have different signs, so what you do is keep same sign or keep higher sign because they're different. Keep higher sign and do what? And subtract. Okay, keep higher sign, subtract, or find difference. One of them gotta win by how much? That's the difference. So different signs, remember to do the difference, which means subtract. That's rule number 1. Rule number 2, well, we're gonna do an example of that later. So when you have same sign, so same. Example here, same sign. So basically keep same sign, keep it, doesn't change. And do what? Do what with the with the values. Keep the same sign, and what do you do with the numbers or the values? Do we subtract or add? What do we do here?
It depends on which one it is. If it's two minus, you would subtract it.
No,
If it's two addition, you would add them, wouldn't it?
same sign. This is same sign. The same sign, what do you do? We keep that same sign, and what do you do with the two values? You get 3. We add them. Okay, so keep it and add. Okay, keep it and add. But this one here, different signs. Subtract. Okay, keep higher sign and subtract. But this one is the same sign. For example, here, we keep that sign and add. A couple of quick examples for this one. Let's do another one for here. What is -3 plus 2, for example? Obviously, they're different signs. Okay, what is that?
-1.
-1. Keep the sign of the higher number and find the difference of the two. For this one, same sign, let's say -4 minus 2. It will be?
-6.
That's right, -6. Okay, so those are your rules for addition and subtraction. That's all you need to remember. These two rules, you will never get the signs wrong. I've seen people in college algebra classes and higher getting these wrong. They're still confusing them and they don't know. Every time it's a different answer. Every time it's a different answer. It shouldn't be a different answer. It should be the exact same consistent answer every time. If you know your rule, you can do this in less than a second. It's faster than a calculator. That's what I always tell people. They rely on a calculator or a phone to do this. I tell them it's faster if you know the rule. You can look at it and literally, in less than a second, you can figure out the answer if you know the rule. But if you had to pull out your phone, unlock it, punch in the numbers, it would take you probably 10 to 15 seconds, if not more. And you may still get it wrong by punching the wrong sign, the wrong numbers. But if you know your signs, your rules, you're actually faster than a calculator. So that's basically addition and subtraction. If we do some more examples like this, we're gonna make some operations, like the order of operations, but with more numbers. Let's say -1 minus 5. That's something that may intimidate some people, but actually it's not. Now that we know the rules, we know what to do. So let's take this one step at a time. Don't try to give me the final answer. What do you think we need to do first here?
-1 in the parentheses.
Yeah.
Get closer a little to your microphone.
-1 in the parentheses.
Okay, so what do we do with -1 and -1? Negative and negative.
You're timesing it, and you're just gonna get 1.
Or what do we call this earlier? So this negative and negative turns into what?
Positive.
Into a positive. That's right. That's what we call
Positive.
a double negative. So when you ever see a double negative, turn that into a positive first, and the expression becomes a lot easier. So you have negative turns into positive. In other words, the opposite of -1 is +1 minus 5. And now what is -1 plus, +1 minus 5? What is +1 minus 5 using?
-4.
Exactly. Okay, so that's basically how you simplify things. It doesn't have to look confusing. Let's see another one, -2, opposite of, let's say, I don't know, +2, -7 plus 2. Okay, so where do you think you start from here again?
From the parentheses.
Okay, so we can say, what is negative? +2. You can think of it as the opposite of +2, which is?
Would just be +2.
No, the opposite of
-2.
That's right, the opposite of -2, as we saw earlier here, okay, would be -2. Bring down the -7. Now we can combine these two. What's -7 take away 2? We're using one of these.
-9.
-9. Okay, so if you see a double negative or a double sign like this, try to simplify that first, turn it into one sign. So these two turn into one sign, which is negative. These two here turn into one sign, which is positive. And then simplify after that. One more, let's say -2 and let's say -5. And let's turn this into minus -1, -2. So think about the order of operations here, and let's simplify this whole thing. Where do you start from with the order of operations?
What's in the parentheses? So
Right.
-1 minus 2 is -3.
Exactly, -3. Bring the other ones down. What do you do after that?
After that,
What needs to be
Then
simplified?
you do -3.
Okay, so what do we do with it?
would it be -5 plus 3?
Be +3. First, you want to turn these two double negative. The opposite of -3 is +3. Bring the -5 down. And finally, this will be
-2?
-2. That's right. Using this rule number 1. Okay, so basically you know all your signs now for addition or subtraction. Just to remember to turn the double negative or double signs into one sign first. Work inside the parentheses first if you have some numbers, and when you add or subtract two numbers depending on their sign, use one of these rules, and you should never get the signs wrong again. As you can see, it's faster when you know the rules. You can do it very quickly without the help of a calculator or a phone or something like that. What else? Okay, so the next thing is 6, so number 7, 6 with addition subtraction. Now we're going to see the rules of addition, multiplication and division. All that we learned so far only applies to addition and subtraction. Do not apply this, do not confuse this with the next section, which is multiplication and division of real numbers. By the way, all this that we did here, we only used integers, but this applies to fractions, applies to decimals. These rules apply to all sorts of real numbers. Even though we're only using integers now, but feel free to apply that to any sorts of numbers. So let's do, so the multiplication and division, we have a couple of rules, basically, just 2 rules you need to think of. When you times, let's say, 2 different signs, a plus and a minus. When you multiply them, the sign will always be, when you multiply a positive and a negative, the result or the sign will always be. So we're done with addition, don't think about this, that's done. Now we're thinking about multiplication. Or in other words, when you times a negative and the negative, what do you get? What's a negative?
Negative times a negative would be a positive?
That's right, the negative times a negative is always a positive. We don't need to know the values of the numbers. We do that when we have addition and subtraction. But for multiplication and division, we just need to know the signs. What if you multiply different signs? positive and the negative. It will always be you multiply positive and the negative. It's always going to be
It's going to
Negative?
be a negative.
negative. Exactly. The same rules apply to division. Division, exact same thing. If you divide negative and the positive, it's always going to be negative. If you divide two negatives, it's always going to be positive. Same rules here. So only two rules here to remember for division and multiplication, and only two rules to remember for this. The other ones are obvious. No need to confuse yourself with them or to try to memorize them. We all know a positive plus a positive is a positive, or when you times two positives, it's going to be a positive. So that's basically your two rules of multiplication and division. Another thing is, do not confuse these two. You see how a double negative and negative here turns into a positive. Do not confuse that with the addition and subtraction. This subtraction here does not turn into a positive, it remains negative. So let's do some examples here for both. By the way, multiplication can be expressed in different ways. Let's say if you have A multiply B, it can also be A parentheses B. This means multiplication as well. Could be A like this. Could also be A period B. Sometimes you use period like this for a dot for multiplication, or it could be just AB. All these basically mean multiplication. AB with nothing in between means A times B, or you could put both in parentheses. All these are symbols or expressions for multiplication. So let's say 2 times -3, maybe 5, and 4 here. Okay, so let's try to do all these. We don't actually need that multiplication here. What is this equal to? 2. There's nothing here. What's the operation?
-6.
-6. Positive times a negative is always negative. What about this?
20.
20. It's positive. The multiplication here is 20. Finally, this one. What's the operation here again in between?
It will be positive.
-4.
That's right. So it's a multiplication. Negative times a negative is always positive.
+4.
Okay, so that's you might see any variety, any form of these variety of multiplications, but remember these two rules. Division is expressed in a couple of ways too. So we have division. The obvious one is the division sign, AB, A divided by B, or A by B, this slash, or forward slash, or division can also be expressed as a fraction, A over B, or A out of B. It is A by B, or division. I don't think there's another symbol for division. That's pretty much the ones we commonly use. Yeah, so now let's do a couple of examples here. Say -15 divide by 3. Let's also do 8 by -2. And also we can do negative, let's say, 20 divided by negative 10. Okay, what is this first one equal to? Negative 15 divided by 3 will be, think about the sign first and then get the value. So we divide in a negative, negative divide positive. Think about these rules. What is the sign of the result?
It's going to be a negative 5.
That's right, it will be negative. Then the value 15 divided by 3 will be 5. This one also division. Think about the sign first and then the value. What is the sign? You have positive, divide negative will be
-4.
exactly negative. Another division, negative divide and negative. The sign will be
+2.
positive. That's right. And then 20 by 10 is 2.
Positive 2.
And that's basically your signs. Let me see. Division, multiplication. I believe we covered all that. Okay, so two rules again, two rules for multiplication and division, two rules here. You know those rules, understand them, and again, you will never get your signs wrong. So let's mix things up a little bit with all this stuff. We're gonna try to mix everything, all the operations together. So maybe let's call this order of operations. Order of operations with all this. So -2 plus 3, -1. You're gonna do that one, and then 15 divided by 3, or -3, multiply maybe 2. And also 18, or -18 divided by 2, multiply -1. So we're gonna mix in everything up here. So, and you're gonna use the order of operations. Start the first one. What do you do first?
-1 plus 5,
That's right.
which is 4.
That's right. 4 to the second power. I'm gonna bring these two down here. What do you do after the parentheses?
The exponents. 4 times 4 is 16.
4 to the second. So before you do the multiplication, you gotta do the exponent. That's 16. Bring the 3 down. -2, and then we'll do the.
Do you do 3 times 16?
That's right. 3 times 6. The multiplication first. Positive times a positive. Be positive. Be
So that'll be
-2. And
wait, we're adding them or multiplying?
here, this is a multiplication.
So would it be 48?
Oh, I'm sorry. That's right. I was thinking about 6 here for some reason. That's right. And what else? -2 plus 48 will be.
It'll be 46.
56.
Say that again.
46.
46. So the sign of the higher number is positive. Different signs, we do the difference. The difference of the two is 46. This one here, we have division and multiplication. Which one do we evaluate? First, think about PEMDAS, and think about the exceptions as well.
We would do division first because we're moving left to right.
That's right. These two are done left to right. These also left to right. So we're doing division first. 15 divided by -3 would be?
Will be 5.
That's right. 5 times 2, which is -5 times 2.
-10.
-10.
That's right. And now the final one. Again, we need to do, actually, let me change this a little bit. It's similar to that one. Let's make this, actually, let me erase the whole thing. Say 4 or -4. And probably 2 here. And then division, -8. Okay, so we'll de-evaluate first.
The first part, which is -4 times 2.
That's right, evaluate the multiplication before the division. Again, left or right, these two together, we're gonna evaluate this. That would be
-8.
-8, division, -8. And what's the sign first, and then the value?
It will be positive.
Negative divide the negative. Looks like here, negative
Like,
divide positive.
+1.
Positive 1. And that's pretty much how you add, subtract, multiply, and divide signed numbers or real numbers. So we mixed up all the signs. We learned the absolute value also, the opposites. Be careful when you compare real numbers. Think about the number line. And these are the subgroups or subset that make up the real numbers. If you ever get confused with the signs, make a small number line for yourself with smaller numbers. Then move right and left until you remember the rules. But these are the two rules basically that will solve all your addition and subtraction problems. And do not confuse those with multiplication and division. Here, these are relatively easier. We don't need to know the values of the numbers to get the signs. Just remember, same signs, always positive, different signs, always negative. And of course, when you evaluate, think about the order of operations. Okay, makes sense, everybody? Any questions about this so far?
No.
Okay, very good. So that's pretty much it for today. Now we're gonna head over to Blackboard and we'll join the discussion board and post any issues, any questions you might still have, and also post the lesson plan and the homework for this lecture, as well as the lecture itself. I'll upload this video next to the unit of homework 5. This will be homework 5. Okay, we have about time is almost up, got a couple of minutes. So if you haven't done so already, go to the discussion board and say something there for today. And look out for the homework and this video itself. We can rewatch it later. And let me know if you have any questions on the discussion board or in the beginning of our next Zoom meeting, okay?
Okay.
Very good. So thank you guys for coming, and I'll see you again next week. Okay, have a good weekend and take care of yourself, all right?
Thank you. Have a good one. Bye.
Thank you. Take care.
Bye.
All right, take care.